database for an e-commerce platform managing a customer's product, other orders and payment. Here our teammates are Devika, Kirtana, Kirti. Let us move to the content. Here the contents are problem statement, entity relationship, schema diagram, SQL implementation, normalization, output, and conclusion. Let us move on to the problem statement. Here the problem statement is based on an e-commerce platform needs to manage a data related to customers like products and orders and payment efficiently. So, without a proper database system, issue like data retendency or inconsistency and slow data retrievals can occur. So the problem is to design a structural database that organize and maintains this record accurately. So let us that the system should ensure data integrity and support a smooth transaction and allow easy access to information. It should also be suitable to handle a real world business operations. These all are the problem statement we have to solve those. Let us move to the entity relationship diagram. Here the entity relationship diagram, e-commerce database ER diagram, where the entity identify the five main tables like customer, orders, order items, products, and the payments. Here, the relationships are based on the one to many, as means a single customer can place many orders, like link like order items acts as a bridge between orders and products. This allows to contain multiple different items. So that point out the primary key has the unique ID for the each record and the foreign key has a connector that links tables together. For example, like customer ID in the order tables. Okay, this is the explanation of ER diagram. Next, I would like to switch to the schema diagram as Kirti or Kirtana.
To explain the schema diagram. The schema diagram explains the structure of the e-commerce database system and shows how different tables are connected using primary keys and foreign keys. The customer table stores customer details such as name, email, phone number, and address. The order table keeps information about customer orders and is connected to the customer table through customer ID. The order item table acts as a bridge between order and product tables, storing product quantity and price details for each order. The product table contains product information like product name, price, stock, category, and seller details. Category and seller tables helps organize product based on sources and sellers. The order item table acts as a bridge between order and product tables, storing product quantity and price details for each order. The order item table contains product information like product name, price, stock, category, and seller details. Category and seller tables helps organize product based on sources and sellers. While the shipment table maintains delivery and tracking information, the wishlist table allows customers to save products for future purchases.
Hi, I'm Kirti. I'm going to explain the SQL implementation of our project. Firstly, creating the database e-commerce. Creating a new database named as a e-commerce. Use e-commerce. Select the e-commerce database so all the further operations happens inside it. Create table customer. Start creating the table named as a customers ID int primary key. Customer ID is type of the integer. Primary key uniquely identifier each customer. In it, no duplicates are allowed. Customer name varchar 100 not null. Customer name stores the customer's name. Not null cannot be empty. Email varchar unique not null. Email stores the email. Unique, no two customers can have the same email. Phone, varchar. Phone stores the phone number of the SQ. Creating the table named as a products. Starts creating the product name. Product ID int primary key. Unique ID for each product. Product name varchar not null. Name of the product is required. Price decimal not null. Decimals is mean by total 10 digits and 2 after decimals. Number of items available in stock is required. Ends the parenthesis and the semicolon. In and next to the creating the table orders and order ID in primary key, unique order ID, customer ID is int, link order to the customers, foreign key later, order ID date not null, stores the order date, foreign key references customers, creating a relationship like create a customer ID in order refers to the customer's ID in customers, ensures only valid customers place orders, and creating the table of payments and payment ID int primary key, unique payment ID, order ID int links payment to an order, amount decimal not null, payment amount is required, payment method like cash or UPI and credit card or debit card, and inserting a customer values like customer ID and customer name, customer email ID and phone number. Same like 5 records are required for this, and inserting into product values like product ID and product name, product price and product stock, same 5, and inserting into order values of order ID and customer ID and order date will be mentioned. Insert into payment values like payment ID, customer ID,
2 minutes
payment
आगे.
method and payment price. And next we'll be moving to the select star from customer. It means
ये नहीं
to explain the output of our project. Select star from customers. Output will be like this. First one, customer ID displays and customer's name, email ID, and phone number. Select star from products. It displays the product ID, product name, price, and stock. Select star from orders. It displays the order ID and customer ID and the order date. Select star from payments. It displays the payment ID, order ID, and amount, payment method also. Select star from, select star from, off, madam. Occupied. Select orders where price is greater than 5,000. It displays the product ID, product name, and price and stock. Um, select star from Select star from orders where order date is greater than 2026, 4 and 5. Displays the order ID and customer's ID and the order date. And select star from payments where payment method is UPI. It displays the payment ID and order ID, amount, and payment method of which whose payment method is UPI or and select star from products where stock is less than 20. It displays the where product is stock is 20. Uh, okay. Next will be explained by the Devika.
Of this assignment. So the normalization is a process of organizing the data properly in a database. So instead of keeping everything in a one big table, this process which is used to breaks it into a smaller tables. So connect item using the relationships. So why the normalization is important? So to avoid the repeating of a same data and also to reduce the errors and to make the data easy to manage in the database. So the normalization, why this important? It reduces the redundancy and improve data integrity. In a e-commerce system, the initial unstructured data may combine customers, product, order, and payment details in a single table, leading to a duplication and inconsistency. So, in the first normal form, all data is made atomic by removing repeating groups and ensuring each field contains only single values. So, in the second normal form, the data is divided into separate tables such as customers, products, orders, order items, and payments to eliminate partial dependencies. So, ensuring that all non key attributes depend on the old primary key. Finally, in the third normal form, the transitive dependencies are removed so that the non-key attribute depend only on the primary key, resulting in a well-structured, efficient, and scalable database design. So next, I will switch to Kirtana R for conclusion.
Conclusion part will be explained by me. The e-commerce database management system helps in organizing and managing customer, product, order, payment, and shipment data efficiently. The ER and schema diagrams clearly represents the relationship between entities and reduce data redundancy through proper normalization. This system improves data accuracy, supports secure transactions, and enables smooth online shopping operation. Overall, the database design provides a structured and efficient solution for managing an e-commerce platform. Thank you.